7b97z69b, trap RF Field Effects C60 beam diffraction, electrons, ions, 5G Wow Seti. There's the alien radio signal. This is about trapped diffracted ions, electron, laser beams, RF Field Effects C60 for UFO space communications. Line 22, SETI data parts A and B. October 4th, 2013. Today's November the 10th. The previous video is line 22, 7b97z69b, Debye-Scherrer, rings, trapped ions, scattering electron beams, 5G Wow Seti. And let's back it up a bit here. So the keyword is trap RF field effects, and there it shows a signal there on the left and the right. Figure 10, the possible effects of the trapped RF field on the scattered electrons was studied by comparing different diffraction data produced by E-beam scattering from a neutral C60 beam passing through trap center with the RF field on, with data obtained with the RF field off. The diffraction data shown on the left indicates that VRF equals 800 VOP produces no appreciable effect on the diffraction pattern. See? Okay, this is consistent with estimates of the field perturbations of the scattering angle and the electron energy. Plots of the signal and background electron scattering obtained for the C60 beam are shown on the right. It's got a little more activity there. These indicate that the electron scattering background is slightly increased by the presence of the RF fields. Apparently, electrons derived from ionization events and beam scattering from apertures are swept out of the trap by the RF fields and increase the measured CCD signals almost uniformly across the detector. The degree to which this might constrain the RF voltage amplitude will depend on the diffracting species. And again, that's from the blog www.genetical.com. October 4th, my thoughts. Figure 10 on the left trap RF field looks like the Higgs boson signal to me. That one there, where it goes up, that looks like a Higgs signal to me. It's like, yeah. Okay. So the formula. Hold on. Formula from data. Let's double check and make sure we got the word formula in the title, and we don't, so we're going to have to add formula at the top here. Okay, sorry about that. Effects plus trap RF field plus scattered electrons. Compare diffraction data produced by E-beam scattering neutral C60 beam passing through trap center 2 superlattices. Laser beam up the middle. See sketches of the fluoroscopy laser beam gun with crystallized mesh structures and electron holes. Electron holes found in line 22's Wow signal data formulas. We'll be cross-referencing lines 1 to 27 with those keywords. RF field on data obtained with RF field off. Diffraction data shown left indicates VRF equals 800 VOP produces no appreciable effect on the diffraction pattern. But it looks like the Higgs boson signal results from CERN 2012. Let's compare the two data forms. See? One on the left and the one on the right. This also looks like a bit of the Higgs signal, but it looks like it's been interrupted in between the signal. So the source is www.genetical.com, where I got the pictures from. So here's another one showing the CMS versus Atlas 2 photon signal plot, February 2012. You see how it kind of looks similar to this one on the left here? It goes up and then it goes like 2 mountains. This one goes up and it's got 3 mountains, and it goes in a pattern that looks almost similar to this one here. So that source is from Vixra, vixra.files.wordpress.com, and that's about the CMS versus Atlas 2 photon signal plot, February 2012. Okay. So October 4th, my thoughts. The diagram on the left almost looks identical to the CMS versus Atlas 2 photon plot signal, February 2000 X-Flyer plot on the left in from Genetical, and that's a C60 beam, right? How did they get that diffraction? Let's go back here. Used a C60 beam trap center. Okay, the diffraction data shown on the left indicates that okay, I don't know. So it's a C60 beam, RF fields, effects of the trap RF field on scattered electrons. Okay, so a trapped. So trap. Oh, yeah, it says that there. Okay. Yeah. Down here. C60 trapped RF beam effects. Almost looks identical to the CMS versus Atlas 2 photon signal plot that CERN discovered. The Higgs boson signal, June 2012 data. Oops, 2012 data. Okay, just so we can refer to it in case we're looking at this years later. Quote, the diffraction data shown on the left indicates that VRF equals 800 VOP produces no appreciable effect on the diffraction pattern. This is consistent with estimates of the field perturbations of the scattering angle and the electron energy. So that's from www.genetical.com. So my thoughts again, we can use this to create a Higgs boson signal with small amounts of energy rather than a large machine that is used at CERN? Question mark. I know we'll figure it out. It might take some time and experiments. Let me know if I am on the right track. Yeah, I'm all thumbs today, I tell you. I had a coffee. Didn't work. On the right track, and your thoughts. Do they look the same to you as well? In the YouTube comments. Yeah. Let me know if I'm on the right track there with it. Like, to me it looks the same, but to you it might not. So if there's something that's different, let me know. Okay? Quote from the blog and my thoughts equals. Figure 10. The possible effects of the trap RF field on the scattered electrons was studied by comparing diffraction data produced by E-beam scattering from a neutral C60 beam passing through a trap center with the RF field on. With data obtained with the RF field off equals diagram from CMS versus Atlas 2 photon signal plot 2012 extra plot. So the keyword to Google, I found a PDF result, pending ionization of C60 and C70 in the next video. Thanks for watching.